Hello, I'm going to give you an answer key to the practice that you did with LOL diagrams and energy calculations that might help you out with the final test. So first I'm going to take a look at the LOL chart. So I'm going to make a drawing to be able to do that one of the person, the bungee jumper. So going in here, and I'm going to make an LOL diagram. So I'm going to use Scribble for mine. And so here we go. Whoa, that is a bad L. And there will be my system. And here's my after drawing. All right, so taking a look at that, I had a man standing on a platform, and there was a bungee, and then there was the earth, and those are the only things that are really involved in storing energy in this problem. And so I'm going to have the man, or the boy actually, and I'm going to have the bungee. So there's a B, and then I'm going to have the earth that all contribute to storing some energy. So there's our system. And then over here, I'm going to draw some lines. Now, how is the energy actually stored at the start of this situation? Well, we have the person standing there, the boy standing there, and the bungee was not stretched. And so there's no energy stored in the bungee at the start. So how, and the man's not moving either. So there's no kinetic energy in him. And so the only way that energy can be stored is that this person is up high, and so there's some gravitational potential energy. So I'm just going to write gravitational potential energy here as an abbreviation right there. And I'm going to say that this person had 4 bars of gravitational potential energy. That seems like an easy number to draw. And so there we have 4 bars right there. All right, so there's our energy for the beginning. Now, as I thought of this drawing, at 1 minute and 39 seconds, I thought that the person was as far down as they could go. Now, if you think about it, when the person is as far down as they can go, at first when they jump off the platform, they speed up, but then gradually the bungee brings them to a stop, and then they bounce back upwards. Okay, so somewhere between going down and going up, they must be stopped. And so I actually thought in this drawing that the point I chose at 1 minute and 39 seconds, I thought that they were stopped. All right, and so I thought that there was no more gravitational potential energy. I thought that there was no kinetic energy. And I did think that there was elastic energy. And so I'll write that as elastic. Okay, and if they started out with 4 bars of gravitational energy, then there would be elastic energy. Oh, wait, let me restate this. The person did not land all the way on the ground. They only went halfway down maybe, okay? So some of their gravitational energy is still there, all right? So I correct that. There is still some gravitational energy, all right? Now, how much elastic energy would there be? Well, we started with 4 bars here. Some of that gravitational energy got stored as elastic energy. How much? Well, half of the gravitational energy is left because they're not all the way down to the ground. So that means there's only half of it left to be stored as elastic energy. And so that is right here. All right. And so now if I draw my equation, I have gravitational energy equals some more gravitational energy, actually only half as much, plus elastic energy. Okay, and again, before has to equal afterwards because of conservation of energy. So 4 bars here equals 4 bars here. Now, some students said that I didn't catch it at 1 minute and 39 seconds. I didn't catch it correctly, and that there was still some kinetic energy. All right, if they wrote kinetic energy, some of them wrote that there was 1 bar of kinetic and then 1 bar of elastic. That would have been absolutely fine if you said that there was kinetic energy, as long as it was clear that you still had 4 bars before and 4 bars afterwards. Okay, a total of 4 bars afterwards. So those people had 2 gravitational maybe, and 1 kinetic and 1 elastic, and I would have been fine with that.